In this segment, we'll talk about if somebody gives you the length of the three sides of a triangle, does it make a triangle? So the general way of doing this problem to find out whether it's a feasible triangle or not is to, let's suppose we look at three sides of a triangle. Then we have to check for all of these conditions. Is A plus C greater than B? Is A plus B greater than C? And is C plus B greater than A? So you have to check whether the sum of two sides is greater than the third side, and all of these conditions have to be true. So let's look at an example of this triangle. Let's suppose somebody says this is 10, this is 4, and this is 7. Not drawn to scale, but let's suppose that's the case. So in this case, let's suppose we call this to be A, we call this to be B, we call this to be C, the lengths of that. So if we look at A plus C, that is 10 plus 4. Is it greater than B, which is 7? Yes. Let's look at A plus B, which is 10 plus 7. Is it greater than C, which is equal to 4? Yes. And then look at C plus B, which is 4 plus 7. And is greater than 10, which is A is equal to 10. Yes, that is true. So that's what we are finding out for this particular case, that it is the correct, that this triangle is possible. Now there's an alternative way of doing this. So let's look at that one. So the alternative way of doing this is A, this is B, this is C, and then we know that the area of a triangle by the Heron's formula. This is Heron's formula. You can go to Wikipedia to find what this formula is about and how it was proven. Is simply S times S minus A times S minus B times S minus C. But we already know the A, B, and C are the three lengths, but what is S? S is the semi-perimeter of the triangle. So what that means is that if your value of what's under the radical sign here is 0 or less than 0, then you won't be able to calculate the area. So what you want to be able to see is that whether S times S minus A times S minus B times S minus C, is it strictly greater than 0? If this is true, then a triangle is possible. If it is less than or equal to 0, then triangle is not possible. So you get a single criteria by being able to do this. So if we go back to the example which we had let's suppose, let's take a different example, 7, 10, and 4. Then in this case, you'll have S will be equal to 7 plus 4 plus 10 divided by 2, which is 10.5. But if you look at what's under the radical sign, what is it? It's 10.5 here, then 10.5 minus 7, then 10.5 minus 4, and then 10.5 minus 10. So what you're finding out right here is that this is positive, that's positive, that's also positive, this is also positive. So whole quantity will be positive. Hence, this triangle is possible. However, if you get a negative number, then that particular combination of the length of the sides is not possible. And that's the end of this segment.